right. Out of curiosity, like show of hands, who here has actually heard of data availability? Is familiar with that? Who here, like, keep your hand up if you feel like you understand what data availability means. Okay, that's more than I expect. All right, so what the whole thesis about, or whole start of this talk is essentially that a lot of questions come up about why Filecoin does not do data availability, or what does data availability mean for the Filecoin network. And I would like to keep this at like a high level and then start getting deeper and deeper into what are some of the possibilities for data availability related to Filecoin, where it makes sense and where it doesn't. And then basically just like start conversation for afterwards, and feel free to throw tomatoes, feel free to point out where I'm wrong on some of this stuff. And yeah, we'll dive into it. All right, so why data availability? Why does it matter? DA has been driving a very significant narrative in Web3 right now. A lot of people are paying attention to it. This has led to, hundreds of millions, billions of dollars of market cap accruing behind this narrative. So it's gained a lot of traction, and a common question comes up. Filecoin is a decentralized storage network. Why not use Filecoin for data availability? And I think it's like there's a lot of discussion around that, and we'll cover a little bit of like what is data availability at the nuts and bolts. How is data availability very different from data storage, and then how that plays into the kind of broader PLN and Filecoin ecosystem now and in the future as DA evolves. So quick primer, what is data availability? Data availability, as it's currently referenced, is really mostly for reducing cost for rollups in the Ethereum ecosystem. So for a rollup to have security, they basically have to submit sufficient data to the Ethereum L1 that they can recreate state, or in the case of like malicious users, be able to return funds. It's basically a backdoor that provides security. It's the predominant scaling narrative in Ethereum. But data availability gets used much, much more broadly than it should. I think many have also pointed this out. So right now, that's the main narrative, and that's where people are looking at it. Obviously, not just Ethereum, but Ethereum has most of the volume. So any rollup could technically use this same paradigm here. Right now, though, it costs a lot of money to put all that data into Ethereum state. There's a lot of things that are coming down to reduce that cost. But if you believe that rollups are continuing to be the scaling paradigm for Web3, you're going to see this problem continue to grow. And that's where a lot of this hype has come from. Oh, this is an old slide. Okay, we'll skip over that one then. So basically, data availability does not equal data storage. I think there's a few, and I've oversimplified this, so feel free to tell me where I'm wrong. But right now, it really refers to kind of the publishing of data, and it doesn't specify anything about ongoing storage or retrieval of the data that is stored. So DA ensures that enough of a network of nodes has received the data, or the call data in this case, that they can recreate the information under specific circumstances. So data storage is actually more about robust access. It has SLAs with your providers. It includes things about latency, redundancy, a lot more kind of specificity around what you need for a kind of large scale performance system. So it's important to split these kind of things apart. And a key point here is that as these systems mature, if it's not explicitly incentivized, it's not likely to happen. There's a certain amount of free lunch that you'll get as you run these systems, but as you get to scale and these things start costing a lot more, people will start looking at how they can do the bare minimum to optimize their costs. So one key point here as we compare data availability versus data storage is I think storage is not a monolith. I think there's a perception that data goes somewhere and that somebody can retrieve it or somebody can use it afterwards. That's not the case. Oversimplifying, of course, but data availability is used more broadly, I think, and everybody looks at this prevailing narrative and says, I can use data availability solutions for data storage as well. There's a whole bunch of reasons why that is incorrect, which we'll go into. But I think it's one way of conceptualizing this is that data availability is a small subset of a much broader kind of data storage solution space. You see this with S3. They have a lot of different options ranging from glacial storage to kind of express, like very hot storage for small data. Right now, we're seeing a lot of people who are kind of subscale, just playing around with data storage in the Web3 context. So expect this to evolve and segment over time. So DA has really lightweight requirements compared to overall data storage. There's a much smaller size of the data. You're looking at blob space that is kind of 100 kilobytes to maybe a few megabytes at a time, whereas data storage can go up to petabytes. The throughput requirements are just not nearly as high. You have, at most megabytes per second. I think the theoretical cap of all the DA solutions put together right now is something around the size of like 20 megabytes to 40 megabytes per second. Whereas data storage, you need CDNs, you need, very fat pipes to be able to serve a lot of these kind of like more mature use cases. Security-wise, data availability has some proofs and incentives that it uses to guarantee that the data is available, whereas like data storage requires SLAs, it requires one-to-one relationships with providers. It requires a lot more than this basic guarantee. So basically, you have also a minimum ongoing reading of data with data availability. There's an initial kind of publishing, there's an initial I have the data and you can check it, but there's really not an ongoing serving of the data, which limits the kind of use cases that you can have for it. And you also have this like very specific way, which might be narrative versus like reality, and we can go into that offline, but about specific attacks that data availability guarantees against versus like what is actually required by the end user. And I think like digressing a little bit, I think proof systems make the difference here. That's really the difference, I'd say, between data availability versus storage. Data availability uses something called data availability sampling. Storage uses multiple different methods here, and this is like a field of research that has gone on for decades. There's retrieval proofs, storage proofs. It's a problem space that's been explored very well, particularly by people in protocol labs. So there's a good understanding of, I think, the trade-offs and where you have to design for. You can't have a system that gives you perfect performance on everything, which is why data availability sampling focuses on giving you very good performance on this very specific use cases. So I think like one way to generalize, and Nicola gave me this phrasing, so I can't actually claim it, but data availability sampling ensures that data is distributed and accessible from a network of nodes without specifying access patterns, redundancy, et cetera, at an individual node level. Versus proof of retrieval storage, this ensures that data is distributed and accessible from individual nodes. You can define with more specificity what that looks like on retrievals, how long they're storing the data, how secure the data is, replication, et cetera. So really quickly summarizing this, I think there's a lot of assumptions about what data availability sampling can and can't do. I think data availability sampling is very good in the situation where you can't trust the person who is packaging up the data and putting it out. It's very good at the publishing part, and it's a very lightweight solution. It doesn't actually guarantee ongoing storage. There's a sampling component of it, but when you're putting the assumptions or the guarantees rely on a network kind of converging on kind of a long-term optimum. So you end up with a little bit of a kind of potential tragedy of the commons situation. And I think it doesn't actually, from what I've seen, it's not mature to the point that you can actually enforce at an individual level incentives for serving retrievals, ongoing data, and these sort of things. This is kind of a big point, I think, once you start looking at more mature systems and much more scale systems, because if you're only serving a few kilobytes of data, if you're looking to be a good citizen within a blockchain, it's okay. People will maybe, run the service to kind of serve all these requests coming in, serve the light nodes, and they'll take a little bit of extra cost. As these things scale up, I think some of those some of those incentives and assumptions need to be re-examined, especially as we see different use cases evolving. If you look on the kind of right-hand side, Filecoin has a very unique set of proofs that also optimizes for different things, I would argue. So I think you have proof of replication, proof of space-time as like the main components of the Filecoin incentive system. What you're guaranteeing there a lot is like replication and ongoing storage of data versus the data sample or data availability sampling guarantee of I publish things and I have a very lightweight way of ensuring that I can get very small pieces of data back if the network behaves logically. And also there's been exploration and within the Protocol Labs network, because they've run these scale systems for a long time, about what retrieval incentivization looks like. Because I think that's the core thing is there's an assumption that data can be retrieved from these networks within a certain amount of time. And unless that's explicitly incentivized, that starts to fall apart at scale. So I think this is like a really interesting area where as these systems become scaled, you'll actually start to see these problems reveal themselves. And a lot of the expertise that Filecoin Protocol Labs network has in this area will become increasingly important. So what are some of the challenges of the current DA solutions? I'll quickly skim through this and we could talk about what I think the interesting areas are of opportunity now and in the future for DA. But there's currently scalability issues with current DA solutions. So a lot of the current DA solutions put all the data through consensus, and they're basically Tendermint based, and you kind of run into the situation where you can max out at like 100-ish nodes, and then you have to kind of increase the node size, as everybody here knows, and that requires kind of increasing centralization, but also kind of limits the amount of storage we can do versus an off-chain solution. You also have a sampling network where you're scaling up, thousands to hundreds of thousands of light nodes to guarantee security and guarantee sampling on that network. that introduces a lot of networking costs, which I don't think have been fully chewed on by a lot of these solutions just yet. And that's network layer capacity is like you have all this orchestration. There's an assumption that you will be able to coordinate very small slices of data that have been sampled by multiple light nodes to retrieve this data and kind of reconstruct data that is lost. So digging into understanding like what that means at scale and like some of the work that we've done with peer-to-peer networks before, I think is going to be a really interesting area. Limited data lifetime. So you don't store data availability. You need to maintain it for up to 7 days usually, so that it can be fed into a proof, which basically guarantees that, the data is there, it has been unaltered, and it feeds into a proof system that guarantees security. Won't go too deep into that right now, but ephemeral storage doesn't give any guarantees for long term. Retrieval incentives, as we talked about, not clear yet how this actually operates in a mature system and at a steady state. And no explicit replication. So the guarantee is that you'll be able to retrieve the data or reconstruct the data under certain circumstances from a network. There's no guarantee of replicating multiple copies of the data that you see in things like Filecoin. So why not just use Filecoin for DA? Not an exact mapping, but if data availability needs are like, I need to get a FedEx package from here or from Manhattan to Brooklyn, I'm not going to take that FedEx package and put it into a cargo ship and seal it up into a big cargo container. I'm going to give it to a courier. Doesn't mean that the cargo ship is not very, very useful and has like a lot of like very interesting things when that package needs to go to different places or that package is different sizes, but it means it's just not a solution that's fit for the exact specifications of what data availability needs at this point in time. So Filecoin, as we discussed, optimized for like petabytes of data storage. Like you have an atomic unit of 32 gigs. There's, some subsections and like small data storage that's being worked on, but you're serving web scale needs versus very small ephemeral data of like the kilobyte to megabyte scale. Proof systems don't solve for data availability as explicitly, although you can use them as like a kind of backup type, which we'll get into, but it's not the highly optimized like lightweight version. It's just different security trade-offs. So including things like replication. So not like the perfect system for DA directly today. How would you approach a DA like solution if you really want to do it? Basically aggregate a bunch of smaller DA chunks and include it into a sector via some of like the pod side stuff that's going on right now. You could utilize proof of space time to basically ensure provable, like the data is there, I can get it. You could negotiate kind of off-band retrieval contracts to get unsealed copies from storage providers, and you could archive the state and offer that as something that DA layers down. So you could stitch together parts of this. It's just from a long-term kind of economic standpoint, it might not be the best solution for the tools there. Like your kind of sledgehammer nail. But some of the ongoing developments could be applicable to DA as DA scales and has different requirements and matures. So I think like the aggregator solutions that are being worked on, snap deals, I think is like potentially could actually apply to this quite well. Upgrades to proof of replication and like just proof work in general. And then as we see hot storage and L2 networks come online, I think that'll actually lend itself much more to where I think the puck might be going in DA. So why does this matter to the PLN Filecoin ecosystem? Because my hot take is that I think the DA market is it's just hitting production. Like you have a lot of these solutions that haven't worked at scale, are dealing with like kilobytes to megabytes of data a day, and they haven't seen really like scale applications of what we call storage. So we have the Protocol Labs network has years of scale storage development. You're building like petabyte scale products. You've scaled petabyte scale peer-to-peer networks through, for example, like Saturn Web3 storage, hot storage CDNs, like large scale data systems that go beyond just the storage itself. You have Filecoin virtual machine that allows kind of like programmable manipulation of the data. Station, which is actually, ironically, they didn't mean it, but they're already a working data availability sampling network that you could deploy data availability sampling nodes to the Filecoin network today, which they already do. They just use a slightly different system for retrieval sampling. So you could rehypothecate that and do data availability sampling today if you needed to. Well, not today, but they'd have to work on it. So I think there's a lot of really interesting things, and like IPC, also scaling Filecoin with recursive subnets, gives you options to play around with designs about how you could actually implement things like DA. And I think this is a really undersold point, is the peer-to-peer, like the networking part of data availability sampling is still pretty underexplored. And I think that's an active area of development where people are trying to figure out how do these light node networks actually guarantee security and how does these work in practice? The thing is like IPFS, libp2p, most of them use libp2p under the hood. Like PL developed it, PL understands it. IPNI ProBlab, all these things were built as like tools that have worked with these peer-to-peer networks at scale. And these are things that are going to be useful for these projects, and they're already looking at as these things scale and hit production. So now let's talk a little bit about how does the DA market evolve. So right now you're seeing Celestia just coming to market. It's just starting to get the first data in. What happens when we start going from kilobytes to megabyte scale to megabyte gigabyte scale? It's like going back to the courier example. Are you going to get 20 couriers to carry, like, if you go from a FedEx package to a crate, are you going to go from the biker to like 20 bikers? It doesn't really work. Then you'd have to like take all the crates off. You'd have to like package them up into things that they could carry. You can't just get them to do that. You need something that looks like a moving truck. So you need a different solution as you scale up, would be kind of like my crude example there. So I think as the DA market evolves, one way is like just from a scale basis, I think you're going to see the need for new solutions or additional kind of add-on solutions to like the basis of what's being built in order to serve the needs that are required. So I think like there's kind of three trends I would say here. Like one is you're going to see new solutions hit production and scaling, and they're going to run into growing pains. And there's a lot of opportunity to kind of support them with the systems they're going to run into, because a lot of these guys are 30 to 40 person engineering teams that have not built these things out just yet. They're incredible teams. Like the Celestia guys are awesome. EigenDA, like EigenLayer obviously is getting a lot of hype, strong team. Avail, who's be speaking soon. Like all these guys are like really, really good. I think it'll be interesting to see how things scale up, how Protocol Labs Network can actually help with some of the learnings from scaling these storage networks that will be, I would say, applicable to data availability. Also, you're going to see an evolution of Ethereum native data availability. EIP 4844 just launched. That introduces like new data availability specific protocol improvements, and dank sharding will be coming in who knows many years, 1 to 2 years, let's say. Which will also like scale data availability and like introduce new primitives. And 3, I think, is like, there's a thread there where data storage is, people are mistaking, or they're trying to use data availability for data storage. And I think you're seeing a lot of this stuff with like the ZK tech. There's a lot of needs for aggregating and like being able to kind of play around with proofs. I think DPIN is going to need very, very different solutions. Like you're passing around gigabyte scale data. There's different access patterns. They can't use data availability for a lot of reasons, although there's like some parts that they could use. I think this AI trend, there's a lot of narrative around like AI will just use DA. It's like maybe for some things, but like, you can't use a DA layer to pass around a training model or pass around a set of inference weights to somebody. And I think there's a lot of interesting things happening with like growth in like media, like video, assets, NFTs, et cetera, which are going to require very different kind of solutions on like composability, mutability, all these sort of things that require an actual storage layer versus data availability. And people are just stuffing them in data availability layers right now. So I think there's a couple opportunities for the PLN. Near term, I think a lot of people are talking about it, archiving state for chains and DA layers. Like DA layers are ephemeral by nature. I think there's going to be a lot of data that needs to be stored, and we're still, both for like some known reasons, then also like reasons for backup, and just like we're exploring what that might look like. I think archiving state for chains themselves is like something that we'll talk about. Peer-to-peer network scaling and monitoring. I think this is a really interesting part, because a lot of these like libp2p based networks are going to need support on how do we run these things at scale and when do we start hitting bottlenecks. There's just like a lot of projects right there with like the libp2p team, like BitSwap, like ProBlab, Station, IPNI, all these projects I think will be very applicable to the kind of data availability narrative. And then I think Station actually is going to be an interesting, I think there's like how do I manage my light node networks, which are very critical to like the scalability and security of these data availability sampling networks. That's going to be an interesting thread to explore, I think. And I think Station is actually well positioned as like a light node platform to do so. Midterm, I think when data availability kind of, you start splitting that and like more defining that better so that like data storage splits from data availability. Hot storage is going to become a thing again, and we're going to realize that a lot of data availability is actually some forms of hot storage. So I think like Web3 storage and Saturn, there's a lot of interesting things I can do there. Also with just like accelerating the speed of existing data availability networks at scale. I think there's like off DA solutions for like DPIN, AIML, large scale proof systems that are going to require a lot of these like more specific solutions. And then longer term, I think there's just like, I don't know, you'd say Filecoin becomes large scale storage provider and access layer for all the chains, like, the glorious vision. But I think there's like really just, it's an immature market, and it's you're going to need a diverse portfolio of solutions for both storage, data availability, and beyond at many layers. So I think it's an area to keep an eye on, and PL is very well positioned in the future. So I'm going to stop there. 2 topics that I'm very curious, and I will nerd snipe that didn't go in here. If somebody wants to argue with me about what consensus actually brings to DA and data storage, I'm very curious to hear much more informed opinions here. I think there's some value. I think it's oversold what consensus actually is required for DA. And then I think there's this theme of the narrative versus reality. It's you have this little Matryoshka doll thing where people will put another layer of decentralization and push out the centralization further and further until it's a little bit of a whack-a-mole. I was trying to get the Scooby-Doo thing where you pull the mask off and it was centralization all along. But if a decentralization continues to push out the front of centralization, at some point you're only as strong as the weakest link. And there's other paradigms like data availability committees that I think are undersold on because people are very, very worried about, we need to have perfect decentralization in all parts. But their perfect decentralized systems actually just have layers of abstraction on top of centralized solutions. So I think there's a lot of interesting things to say there. Cool. All right, that's all I have. But would love people to throw tomatoes. Any questions? Go away.
So what drives the need in your midterm? Go back to that slide. What drives the need for decentralized CDN acceleration?
Well, I think you're starting to see Espresso and others, they're already starting to realize they need CDNs. We have our backup, which is the traditional kind of data availability sampling the network will provide. But in order to get the speed and latency you need for use cases like shared sequencers, you need to be able to get that data back very fast and with reliability. And I think that's not guaranteed by just base data availability sampling systems. So as you start seeing a little bit more scale and as the dust settles a little bit, people are already looking at CDNs to make sure that they're getting the data in the right place.
What kind of latencies are they looking for?
I don't think that's been well defined, to be honest. Sorry, Hanny, your hand up.
I was asking, but one thing that people say CDN, had the point of that CDN, that's what you see in, but a lot of the time, everything in what you running a little slower, so everybody with the CDN, I just want that.
Yeah.
I don't want to have to deal with coming slow.
Yeah, I would say I wouldn't bullshit. I think it's just not defined well enough yet because a lot of these systems aren't in production, haven't had the end users yelling at them for being slow.
But yes, that's one or two, then said, that's not fact, but you don't need to get just ask you at the time. Right?
Yeah.
You got so there's already been their pipeline got much higher than yeah, that's much easier. Yeah, that. I think the answer is specific to the specifically dot have it. So different levels just have different dot sizing and dot play. You think about the time for the available level just and then you split that time in that direction basically. And you both the time so that nobody or it takes too long or general public to verify then that the next spot content time that say that the item part and say that usually it's seconds block there's but it's seconds for a lot of people. It's just is why the CDN could make sense. It's more about doing the own rather than dividing it. Right, so it's just by replicating it, you see the number of data that you can get on set for all the data. yeah, like with regard to perspective, like you want to use that like the days that you talk to like input to cut if you really dial back, and then it's like we're talking about like you can have availability is really slow, but always talk to a person that only people that put close to then you're reasonably specialized who had that where like right just geographic. Totally. I think I simply you still feel like you just stop things it's
I think some examples are like, so I think there's narrative versus like reality. I think there's like narrative of like you see the Twitterverse is like, oh, we were running like decentralized AI on top of DA layer X, and it's like, okay, well you though you spun up the website two days ago, so like pump the brakes. But I think there's like some interesting stuff where people are doing like large. I talked to one project that's doing kind of like large scale machine proofs where they're trying to put like giant machine logs on chain and be able to access that in a way that they can, create like a verified proof that's of identity for like a specific machine. So they just haven't found. They're basically just trying to find a better solution for these like very, very large scale machine logs. And the best they can do right now is just stuff it in their roll up state and then like use DA or do that. But that runs into a lot of problems when they can't access the data after 7 days, or they can't just get like retrieval of like a 5 meg file. So I think it's like the kind of backup solution is either like they're doing it in IPFS or they're they're doing a roll up and they're storing it in the chain state over like several blobs, and then assuming that like the DA layer at this point will just be able to lower the cost enough that they can like do what they need to for the short term. Again, it's just like it's DA is very good for very specific things. Storing and retrieving or querying like very specific data that needs a lot of access is not potentially the best use for it.
You some research to other feature if like ones of that.
Oh, I'm not a researcher, so I won't put my neck out on that one. But I know it's been an active area of discussion among the Filecoin team. I think they've looked at it for a while, but I don't have a roadmap or anything there. Just an anecdote of a teaser that there's stuff ongoing. How applicable that is to specifically to DA versus like a kind of there's enough lineup of the DA use case TBD.
Top it.
Yeah. Top it. All right. Oh.
So you talk about DA as like kind of a separate thing, though, like blockchain type DA, that's part one, right? So how do we start thinking about like what is this like separate other thing that we're all DA versus like just posting stuff the one thing?
Yeah. I mean, I think there's like two things there. It's one, it's just like you could view DA as like as simplest as like a cost reduction for posting DA. So like all DA solutions are, I am like taking the arbitrage of I can at the very simplest I stuff in another chain state, and I don't have any other guarantees, but that chain state has like cheaper storage, or I can like put it into chain state for cheaper than the other. So like step one is I just reduce the cost, which is like pretty significant, and that's not something to blink at. Like I think there's like 90% plus reduction in cost, which is actually making a lot of things feasible that weren't before. Like I a couple examples. I think like the PGN was a public goods network because public goods maxi too, but like they weren't able to run until they onboarded a DA solution, and all of a sudden they were able to be profitable and continue distributing the public goods and like run Gitcoin. So that's a cool example there. I think it's like in terms of defining what is DA versus not, I think like right now, the primary use case that most people have been using Web3 quote unquote storage for is just like DA, because it's like most of the data is generated in a Web3 way and needs to be secured in a Web3 manner, is transaction data. And that's why DA solutions make sense. I think and that's because the end user is typically a DeFi institution that like needs to have that track record of transactions. When you start seeing things like, oh, we're going to do social, or we're going to do gaming, like those assets don't need to be, it doesn't need the necessarily like the transaction type security that you're going to see for a DeFi. So once those use cases start taking off, I think you're already seeing like different ways that people are interacting with like, okay, well, maybe I just need to put a commitment and then have like a guarantee of the data being able to be queried from another source. Maybe that's like I host my own IPFS node and I just pull it there, which creates another DA problem, but we won't touch on that right now. It's just these emerging use cases, I think, that will come in this next cycle, and hopefully come in this next cycle beyond DeFi. That's going to drive a different set of user needs, which is going to have different kind of like access patterns, different requirements for security, and different requirements for scale. I don't know if I answered your question correctly. All right.